Good afternoon, everyone. Thank you very much for coming back. I'm happy to see there's still a lot of you here. So I'm sure most of you have heard of blockchain many times recently, and especially cryptocurrencies. We have seen cryptocurrencies keep rising and falling. But actually, beyond the cryptocurrencies, blockchain can do a lot more. And in this talk, I'm going to share with you something that is very different from cryptocurrencies, namely something that's some real things that blockchain can really help. Before we move on, let's look back to 2016. What happened in 2016? Many events, important events happened. Some of them are about voting. We have the US election, we have the Brexit voting. Voting has been a very common and important thing in our life, in our society. So normally, when we do voting, we need to go to some polling station and to vote, and then some certified or authorized people, they will do the tally of the ballots. Namely, they will count the ballots, and at the end, the voting result will be released. But what's the problem in existing voting system? There are many challenges. One thing is the privacy. Certainly, we don't want other people to know what we vote for. Of course, there are some cases we don't care. Another important thing is cheating. There can be many cheating in a voting event. How can we prevent, how can we detect, and how can we eliminate cheating from the voting? And in almost all existing voting systems, we need some third parties. They should be trustable. And there are other things that we want to have. We want the voting can be verified. We want it can be audited. So can blockchain help in this scenario? This is a real things in our life. Can blockchain help? So let's keep this question in mind. And at the end of the talk, you will have your answer. Then what is a blockchain? Blockchain is actually about trust. For example, in real life, we trust the banks. So we put our money in the banks. The banks keep the money for us. They keep the ledger for us. We trust the bank. Do you really track your ledger very often? Not really. For myself, I actually don't care. I trust the banks to keep the record of my ledger, of my money. But with blockchain, we actually don't need banks. We can form a network. Each of us, we can keep the records on our own. I can keep my own record. You can keep your own record. She can keep her own record. He can keep his own record. But so many people are keeping the records. Then how can we make sure that different records, they are consistent with each other? So we have the consensus mechanism comes in. For Bitcoin, we have the POW, proof of work, and there are many other consensus mechanisms to ensure that different records, they are consistent with each other. And with blockchain, we can also enhance the privacy. Like for Bitcoin, you have your private key. You keep it on your own. You don't give it to any other person. But you can give out your public key. And especially when other people transferred Bitcoins to you, they just transfer to your address. And what is your address? Your address is certain random number of your public key. So this can enhance the privacy. And there are also many other things regarding the privacy. But actually, beyond just doing transactions, blockchain can do a lot more, especially with smart contract. As Ethereum does. Ethereum, you can regard this as a worldwide computer which never stops and is not owned by anyone. And you can run your smart contract. And what is a smart contract? It is that you can turn your business logic into code and let it run on Ethereum or other blockchain network. It will automatically be executed. For example, if Gary and me, we are doing a game, say we are bet on something, like say whether it's going to rain this evening or not. If it rains, then Gary wins the bet, and he will win $10 from me. So we can use smart contract. If without blockchain, we may need someone that we both trust, and we put our money to him. And when the event happens, say it rains, then the trusted party can give the $10 to Gary. But with blockchain, we don't need such trusted party. Both of us, we use a smart contract, so both of us will have $10 being locked by the smart contract. And when the event happens, then the smart contract will execute automatically. No one can stop it. So with smart contract, we can do a lot more things beyond transactions. For example, let's say there are already an association of many banks and insurance companies or financial companies. They already form a blockchain network to do transactions with each other. Or you can also consider other scenarios that there is a blockchain network. They want to, beyond transactions, they want to other things. They want to do more complex computations over the existing network. And you know, for a blockchain network, naturally there's no trusted third party involved. So in such situation, we also require that no trusted third party is involved in such collaborative computation. And so what else we can do over a blockchain network? We can do voting. The network can vote, say they can use it for election of certain leaders, or they can use it for approval of certain policies. They can also use, they can also do auctions on the blockchain network. Especially, they can also do collaborative computation across multiple databases while preserving the ownership and also the privacy of the data and the databases. This will be very attractive, especially in banking. Blacklist is a very important thing. So if the banks and insurance companies and other financial institutes, they collaborate together, they can query if a client belongs to anyone's blacklist. We can actually do more. Namely, probably certain client is not on anyone's blacklist. That's quite possible. But if they collaborate together, they may find out that this client should be blacklisted. So namely, they can do these kind of complex computations while preserving the privacy and the ownership of the data. So you see, there are a lot of things beyond just transactions we can do over a blockchain network. So then how do we enable such a collaborative multi-party computation over a blockchain network? This is just a very brief and general framework for it. Let's look at the structure of a blockchain network. There are ledgers, and there are smart contracts, and there are various participants using their client applications. Namely, this is something that is special to blockchain. Why? Because we have the ledger, which is distributed and with consensus. We also have a smart contract, which is automatically executed on a blockchain network, and also with consensus. And the third type of components, namely those client applications, is just normal. So when we do multi-party computations on a blockchain network, we need to divide this into these three components. On the client applications, it will do those off-chain computation, which needs a lot of resources, computing and computing power. And the client application will communicate with the smart contract, and it will read data from the ledger. It doesn't write directly to the ledger. It will write to the ledger through a smart contract. And smart contract will do trusted on-chain computation and verification with consensus of the network. And it can read data from the ledger, and it also can write to it. And the ledger plays the role of a trusted record of the data. Well, you may think that this is too abstract. I want to see something that is real, that is more concrete. Sure, then let's go back to voting. So actually, there have been certain voting events happen on blockchain, especially on Ethereum. There have been two famous voting events for Ethereum. One is the DAO hard fork voting. What is DAO? It is decentralized autonomous organizations. It was built in the middle of 2016. And it is meant to operate as a venture capital fund. And there's no central authority for it. So there's no cost for these central authorities. Namely, you can save a lot of cost. And the investors, they control the fund on their own. However, this DAO was hacked, and a lot of money was about to be lost. So the community, Ethereum community, they need to prevent the loss of so much money. And at that time, the money was $250 million at that time, and now it could worth billions of dollars. That's really a lot. So the community, they decided to vote either they want to recover the loss or not. So they need to vote for the community. And another recent voting event on Ethereum is to reduce the reward to the miners. Ethereum, they want to transfer from POW to POS, which requires much less computing power. However, on Ethereum, there's no official voting mechanism. So they need either to use a third-party voting system or need to involve certain trusted party to do the voting. So we see that there's need for voting over a blockchain network. And as the ecosystems grow over blockchain in the future, there will be a lot. Then it will be more demanding for such a voting mechanism. But it is very challenging to design such a voting system on a blockchain. And mainly there are the three challenges. One is privacy. If you don't care about the privacy, then it's very easy to solve. And another one is how can we prevent, how can we detect, and how can we eliminate cheating? And the last one is by the nature of a blockchain network, there's no trusted party involved. So if we are going to involve certain trusted third party to help the voting, then it doesn't make sense, right? So it would be ideal if we don't need any trusted third party to help in such a voting event. So to solve this problem, I designed a new voting protocol over blockchain. This one has been patented, and we have submitted to IEEE Cloud. There are two key ideas here. One is distribution voting. I will explain it later. Another one is distributed tally, namely distributed counting. So what is distribution voting? Normally, voting, you have one ballot. Normally, you have one ballot. You can choose, say, you can choose one of the options that you prefer. But what if we break one vote into many small ballots, so that you can distribute your ballots to the options? For example, two options, A and B. Then, based on your personal interest, you may put all of your ballots. Say you have 100. You may put all your 100 ballots to option A. But some people they may think that although I like A, but I also don't hate B. I also a B like B also. So you may distribute your ballots to the two options. For example, you may put 80 for option A and 20 for option B. So this can provide you, namely, it's not yes or no. You can have certain thing in between. And with distribution voting, we can then have the benefit that since you have 100 ballots, if I only know one or two of your ballots, I actually don't know what you prefer, right? I only know one or two. Say, I may know that two of your ballots, one is for A, one is for B. Then I still don't know what you prefer, right? I can get only, other people can get only a little information of your ballots only. This is the first key idea. The second key idea is that because there's no trusted third party involved, especially in the counting stage. So everyone participate in the counting. Everyone will count a small portion of the ballots, and then you need to you need to publish your counting result, and other people will verify your counting. And if all participants' counting are correct, then we simply add all together, then we get the result. So this is the second idea. And this picture shows there are 5 stages here, and it also shows how the client applications communicate with smart contract how smart contract communicate with the ledger. So this is in this a concrete example for this general abstract framework. Okay, next I'm going to explain how it works. It will be technical, so may not be easy to understand. So first stage is simple. You just encrypt your ballots, each of your ballots. But the requirement is that you encrypt different ballots using different other participants' public keys. And then you broadcast all your ballots to the blockchain network, and then smart contract will verify your ballots to avoid double voting. Namely, some people they may vote more than 100 ballots. In this case, the smart contract will just get the first 100 ballots, so we'll ignore all other ballots. This can prevent the double voting. So the first step is kind of simple. But the second stage is a bit tricky. Since there is no trusted party to verify anyone's ballot, so everyone needs to collaborate together to do the verification of the ballots. So since since your key may be encrypted, may be used by certain participants to encrypt their ballots, so you can get from the ledger all those ballots encrypted using your key, and then you can decrypt them. You cannot decrypt others, but you can decrypt those encrypted using your public key. So you can verify each individual ballots. If there's anyone invalid, then you need to report it. So you verify, then you report. So this is the first verification, first phase of the verification. And the second phase of verification is done by smart contract. Namely, smart contract will receive everyone's reporting, and then will verify everyone's reporting. Some people, they may report some valid ballots. This is cheating behavior. And some people, they may not report certain invalid ballots. This is also cheating behavior. So smart contract will verify it. And why can smart contract verify it? Because here we use homomorphic encryption, which allows the smart contract to verify each one's reporting, whether it's valid or not. And at this stage, smart contract will identify who is cheating, and will generate a blacklist of those cheating participants. So since let's say there's the blacklist is not empty, so it means someone is cheating. Okay, we know from the blacklist we know who is cheating. Then what do we need to do? First, we need to ignore those ballots of those cheating people. Their ballots shouldn't be involved. This is kind of punishment. If you cheat, your ballot will be excluded. First thing. Second thing is that any cheating people, they shouldn't participate in the tally stage. If someone cheats, he cannot count any ballot later. So this stage will need to first we will need to exclude those ballots those ballots of cheating people. So those ballots will be put into blacklist. First thing. Second thing, those ballots encrypted by those cheating people, they need to be revoted. Namely, they need to be encrypted using other non-cheating people's public key. So we need to replace them. This is stage 3. And after this stage, if there's no more cheating, then we can proceed to the counting stage. So once again, since there's no trusted party to do the tally, so everyone who are not in the blacklist will participate in the tally stage. They will count those ballots encrypted by his public key, because he can decrypt it, so he can see so he can see all those ballots and thus can tally them. So after tally, then he need to publish his tally results. And once again, smart contract will verify everyone's tally results. Since homomorphic encryption is used, the smart contract can verify anyone's counting, whether it is correct or not. And at this stage, if anyone is cheating in the tally, he will be put into the blacklist again. He will be put into the blacklist, and will then repeat the stage 3. And once there's no more cheating in tally, then everyone can just simply add all the partial tally results together, then can get the final results. And this picture shows the voting flow of this protocol. So you can see there are at 2.2 and 3.2 and 4.2, it will if there's any cheating behavior being discovered, then we'll repeat certain process, and at the end, until there's no more cheating. So you can see every party, they collaborate together on the detecting, on the verification, on the detecting, and on the tally of the ballots. And with this protocol, we can achieve the privacy. Why? Because your ballots are divided into many small ballots, and other people, they can know only one of your ballots. So of course they can collaborate together, but unless enough number of them collaborate together, otherwise they can just know a little of your vote. So this can protect the privacy. Certainly, it is not perfect, with little cost. And naturally, you can see there's no trusted party involved in this process. And also the detection of the cheating and the correction of cheating. Any cheating behavior can be detected and can be punished. So with this, we achieve a privacy-preserving voting protocol on blockchain. So with smart contract, blockchain can do a lot of things beyond transactions. And multi-party computation on blockchain can empower the participants of the blockchain network to collaboratively achieve certain common goals. But it is challenging to achieve privacy, security, and to prevent and to detect cheating, or to achieve all these things at the same time. But we can still do something for it, like the voting protocol I just presented. So, and in in this talk, I already presented a framework for such a general brief framework for such collaborative computation on a blockchain, and presented an explicit example application of it that is for voting. And we can do a lot more, especially for databases, namely collaborative computation among multiple databases while preserving the privacy and ownership. But this is still in progress, so I don't have much to share at this moment. Okay, thank you very much. Any questions?